All right, here we go. Today, 5.5, distributive property. All right, let's say you wanted to multiply something, like this, like 7 times 14. Now, there's a couple ways you could do this, but one way is through what we call the distributive property. And let me show you how that works. And it's basically what you would do anyway when you're talking about multiplying. All right, so what you can do is this. 14 is simply 10 plus 4, right? So if I don't know what 7 times 14 is, that's okay, because I know what 7 times 10 is, and I know what 7 times 4 is. So I'm going to do this. I'm going to break this up. Okay. 14 I broke up into 10 plus 4. And now I can do it really easily. I can say, well, 7 times 10 is 70. And 7 times 4 is 28. And I add those together. And so now I know that 7 times 14 is 98. So if I don't know 7 times 14 off the top of my head, that's okay, because I can always break it down into smaller pieces that I do know and then add them together. Right? Does that make sense? Like that's what's happening. So what is the distributive property? This right here is the distributive property. The idea that you distribute the 7, whatever's on the outside of the parentheses, you multiply to each part that's inside the parentheses. Right? Now, a real common mistake is some people forget to do the second number. Some people just, they make an error and they're multiplying, things like that. So there's lots of places to make mistakes. So how does this work, right? Again, because as you can see, I just did 14 is 10 plus 4. So it's basically like if you were to regular multiply this, wouldn't you be doing this, right? If it was like, this is how you guys learned how to multiply, right? Well, 7 times 4 is 28. 7 times 1, but it's not 1, that's actually a 10, right? Which is 70 plus the 20 here, which gives us our 98. Right? Well, that's exactly what we did here. 70 plus 28. Try this one. Do this one all in your head, though. Okay, I just want you to do the final answer. What is 6 times 15? Do it in your head. You don't have to write it down. See if you can figure it out. Do this one in your head. Does it work? You got it? Yeah. You guys, I'll give you guys a few more seconds. Try it in your head. Remember, 15 is 10 plus 5. So that's 60. And that's 30, which means you should get 90. Right? So we actually use the distributive property, right? We actually kind of use it. It's just breaking apart something to make it a little simpler for us. We use the distributive property to help us kind of all the time, right? So that's what the distributive property is. This step right here, I'll circle it again, is what we call the distributive property. And there's a question in the chat about why does this work? Because we showed how it works. That's the property, right? That's how the numbers will work. Kind of like when we talked about properties yesterday, like why are we the commutative property? Why are we able to add in any order? Because the commutative property says we're allowed to add in any order and it'll still be the same, right? So why are we able to do this? That's what the property is, distributive property. Okay, so this is a good, useful tool in a lot of ways, and I'll show you maybe an example later how this works. So let's go over it. Let's put it into our notes, kind of in our a way that kind of looks with the algebra. So here is the distributive property. Okay, if you have A times B plus C, that's the same thing as A times B plus A times C. So using an example of that, right? Let's do I'll write an example kind of just like the one we did above here, right? So for example, if I had 8 times 13, or sorry, times 10 plus 3, which is 13. And again, normally you use PEMDAS and you do the in the parentheses first, but actually you don't have to if you want to do it this way instead. That makes it easier. You will see with letters why we can't do that later. Okay, so again, that's 80 plus 24, which is 104. Right. The other way you could look at this, okay, is you could do it works with subtraction too, and that's where it gets a little more confusing. A times B minus C. Same thing though. Is A times B minus A times C. Now here's an example of when this is like super handy. Let's say I had something cost $99 and I had to buy 4 of them. Okay. Um, and I had to buy 4 things that were $99. So I'm gonna say, okay, what's 4 times 99? Well, 4 times 99, I don't know that off the top of my head, but what I do know is this: isn't 99 the same thing as 100 minus 1? Right? Isn't that 99? So if I had to multiply that by 4, check it out. 4 times 100 is 400. 4 times 1 is 4. The minus stays. Now the minus, negatives and minuses, that's what gets us really, really confused. Okay. And then 400 minus 4 is 90, or 396. Okay. So again, the distributive property is super helpful in this way. If you ever like, you know how like if you go to the store and everything is not, it's not just $5, it's like $4.99. Well, what you do is you can multiply everything by 5 and then subtract away that extra cent later, and that's a good kind of trick for that. Okay. All right. So let's do an example here for you guys to do. All right. Let's say you had this 8 times -9 plus 4. Now, again, you could add the parentheses, what's in the parentheses first, but let's not. Let's just practice distributive property real quick. I just want to make sure you guys can do it, okay? So go ahead and distribute. I want you to draw the arrows. I want you to write underneath what it is, okay? This is just kind of practice for this. And then if you can, at the end, add the numbers together, then go ahead and add the numbers together. All right, go ahead and put in the chat what you got on this one. Once you got it. Thank you. All right, answers are coming in the chat. Good job. All right. Good. Yeah. 8 times -9 is -72. 8 times 4 is +32. I'm adding these together, so I should have ended with a -40. Good. All right. One more I want to show you guys just with the numbers, and then we'll get into the algebra stuff with the letters, is a problem that looks like this. Now, the number 9 is on the other side, which is weird, and I don't like it there either, but it's okay, because remember, the commutative property says we can multiply in any order. So, and even though the 9 is on the right side, it's okay. You do the exact same thing as you did on letter A, okay? So the 9 still distributes. Now, sometimes people ask me, Mr. Leong, is that a minus sign or is that a -8? And the actual answer is it's a minus sign now, but you can make it into a -8 if you really want to. If you prefer to do keep switch change inside that parentheses, that could also work. Because I know negatives kind of throw us off a little bit. So you could either look at it like this, or if you want, you could say this is 12 plus a -8 times 9, if that helps. Okay, so hopefully some of you guys saw that I did a keep switch change in there in the middle. The reason why some people like this is because then you're always adding. That's why we do keep switch change. I'll leave it up to you on this one. Okay, so let's go ahead and do this problem. I'll do it on both so you could see. 9 times 12 is 108. 9 times 8, okay, 72. 108 minus 72 is 36. Or, and I know some of you are thinking, well, Mr. Leong, wouldn't it be easier just to be 12 minus 8 and then multiply? Yes, it would be. But we're just practicing with the distributive property, okay? Or we could say this, 9 times 12 is 108. So I'll do this in different color so you can see. Plus a -72, which still equals 36. The minuses are going to get us. I know that. That's one we have to spend extra attention on. Okay, so now what does it look like with algebra? Okay, so here's where it gets tough. Six times a plus 4. Now, what people don't like about this is that the final answer is actually, it seems unfinished. And let me tell you what I mean by that. Okay, so let's do this one together. 6 times a is 6a. Six times 4 is 24. This is your final answer. Whoa, wait a second, Mr. Leong. Doesn't that become 30a or something like that? No, look. This is something that we're going to learn a little bit, I think, in the next lesson. This is what we call like terms or unlike terms. Like, this has an A. 6a has an A with it, okay? 24 does not. So the problem is, if you do not have an A with it, it doesn't work. It's kind of like saying, I have 6 apples and I have $24. Do you add those together to make 30 apples? No, right? You keep them separate. Okay, so this is actually the final answer, and that's what gets people a little bit confused. On your IXL, there's a lot of questions that end up looking like this, right, where you have to multiply it, and then you leave it as is. You do not combine those things. Okay, so that's what's really tempting. That's what people want to do, is they want to combine them. So here's another example, and this one I want you to try and do on your own and then put in the chat. Okay, what if I had something like this? 4 times x plus 7. Go ahead and do this one. Put it in the chat. Good job. Yep, and you got it right. Good job. Good job. Yep. Maya. Good job, Joaquin. Good job. Good job, Kelly. Yeah, good job, Justin. Excellent. Let me tell you a common mistake that I find. A lot of people do it like this. They'll draw the arrows, and they'll do this. Okay. This is a mistake that I see a lot, right? And what happened? Okay, I distributed the 4 times the x. Everyone gets that part right. A lot of people get the second part wrong because they forget to distribute. They forget that the arrows mean multiplication. So you have to make sure you multiply there. 4 times 7. Okay, 4 times 7. So that's not going to be 7. 4 times 7 is 28. And again, you can't combine them, right? I've got 4 xylophones and $28. That does not mean you have 32 xylophones, right? That's your final answer. Now I know some of you are thinking, Mr. Leong, that's not too bad. This is pretty doable. I can do this. Not too bad. And that's good. It is. It's not too bad. Except it gets a little bit more difficult once we start dealing with some negatives. So let's do that. Okay, this one's a little trickier. Try this one, letter E. All right, seems like we're getting it. Got a few people putting in the chat. Good job. See if we can get a few more. Awesome. Negative 12y. And again, you could look at this 2 as a minus 2. You could just cover up a good strategy is to kind of cover up the negative 4y, okay? And then you get, you end up with just a negative 6 there. Okay, now again, can I combine these? No, you can't combine them. That's it. This is the final answer right here. This does not become negative 18, right? I have negative 12 yaks and minus $6. You don't combine them, okay? Sorry, I couldn't think of anything else for the letter Y. Okay, that is your final answer. Okay, it feels uncomfortable. It's like that feels unfinished. Mr. Leong, you always tell us to simplify. This is the simplified version right here. Okay, last problem, hardest one I can make. Some of you guys are like, these aren't hard. Okay, this one will be a little bit difficult. Not too hard, but you got to be real careful with this one. And some are thinking, this isn't challenging, Mr. Leong. This is where it gets a little bit tricky. I have some questions about can letter E be negative 18y? No, again, you cannot combine something that has a y with something that does not have a y. So negative 18y will not work for letter E. The letter E, that's the only answer that you could have. All right, so some of us are getting a little bit tripped up on this one, but I thought we would. Okay, check it out. On this one, everyone's got this right, negative 2x. Now here's what's tricky, okay? Is this a minus 8? Is it minus a positive 8, or is that a negative 8? And whichever way you look at it, you can look at it either way. It's actually fine. So think of it this way. The way I like to look at it is say, okay, this to me is like a negative 8. So negative 2 times negative 8 gives me a positive 16. Or you could have looked at it like this. You could have said, well, no, Mr. Leong, that's a positive. This is a negative 2x. This is a positive 8. Negative 2 times 8 is negative 16. But remember, if you do it this way, then that negative needs to drop down. And you end up with a negative 16. Well, a negative 16 changes to a keep switch change positive 16. And no, this is not negative 14x. Okay. So hopefully you see how that had to become positive. Did everyone see that? Right? How that negative, those two negatives make a positive. That's the tricky part. And we're going to focus a lot more on this tomorrow. I know, sorry, we kind of rushed here, but this is difficult, again, with those negatives. And for the IXL, just try to do your best. If you don't get all the way up to 80, that's okay. We'll actually practice a little bit more on the next day as well. So this is tough. This is kind of tough stuff. This is stuff that takes a little bit of time, a little bit of practice. But once you kind of get the hang of it, then you'll be okay. All right. Okay.